Okay, in chapter 12, we are looking at sequences and series. So sequences are going to be ordered lists generated by a function. For example, the function f of n equals 100n. I would plug numbers in for 100, so f of 1 would be 100, f of 2 would be 200, etc. A sequence is a function that has a set of natural numbers as its domain. Sequence. Okay, so sequences are going to be written as ordered lists. A sub 1 is going to be the first element, A sub 2 the second element, and so on. So if I wanted to say find the 10th term in that list, I would say A sub 10. We're often specified by given a formula for the general term or the nth term, so n meaning that term in the sequence, so A sub n. So for example, let's find the first 4 terms of this sequence here. So A sub n equals n plus 1 over n plus 2. So if I want to find A sub 1 as the first term, I'm going to plug a 1 in for n. So this would be 1 plus 1 over 1 plus 2. And that would give me 2 thirds. Then I want to find the second term. I'm going to plug a 2 in. So I have A sub 2 would give me 2 plus 1 over 2 plus 2. And that's going to give me 3/4. A sub 3 would be 3 plus 1 over 3 plus 2. And that would give me 4/5. And then A sub 4 would be 4 plus 1 over 4 plus 2, which would give me 5/6. So the first 4 terms in the sequence we would say would be 2/3, comma 3/4, 4/5, and 5/6. When we put them in the list like this, you can clearly see the pattern that each numerator is going up by 1 and each denominator is going up by 2. Next, we have two different types of sequences. So you have a finite and an infinite sequence. So a finite sequence has a domain in a finite sense, which means it has a definite ending. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has a definite ending here of 10. Whereas an infinite sequence does not have an ending. Okay, so the domain would be all sets of natural numbers, so it would have an ending of infinity here. So this is dot, dot, dot. Your little ellipses here telling you that this has no ending. Okay, so for example, the graph of a sequence, if we're going to graph a sequence, that is going to be given to you just like a linear graph. So you have f of x equals 2x. Now, if I'm graphing a sequence, it's just going to be discrete points. Okay, so these points here, and we're not going to connect the line. So that's really the difference here with our graph of a sequence. The next type of sequence we have is a recursive sequence. So this is given to you by specifying the first 2 terms of the sequence, and then use a formula to specify subsequent terms. And let me show you what this means here. So for example, we have the first 4 terms of the sequence where the first term is 4. So they're going to give you the first term. And then it wants you to find the first 4 terms. So A sub 2, 3, and 4 here. This is indicated that it's recursive by this n minus 1 here. So if you see this n minus 1, that is going to indicate a recursive sequence, which means you're using a previous term. Okay, so for example, you have A sub 1 is 4, and you want to find A sub 2. So we're going to plug 2 in for n into this formula. So you have 2a to the 2 minus 1 plus 1. Okay, well, what this means then is that's a to sub 1. So 2 minus 1, 1 plus 1. So this is 2 times a sub 1, our first term, which happens to be 4, and then plus 1. So this is 2 times 4 plus 1. So we're using the previous term in the formula to get subsequent terms. So you have 2 times 4 is 8 plus 1, which is going to give you an a sub 2 of 9. Then if we want to find a sub 3, same thing. So we'll plug a 3 in for n. We have 2a to the 3 minus 1 plus 1, which means this is 2a sub 2 plus 1. A sub 2 is 9, so we're going to plug a 9 in for a sub 2. So we have 2 times 9 is 18 plus 1. We get a sub 3 is going to be 19. Then you have a sub 4. We do 2a to the 4 minus 1 plus 1. That's going to give you 2 times a sub 3 plus 1. And we have a sub 3 is 19, so 2 times 19 plus 1 will give us a 38 plus 1. We get a sub 4 of 39. So we have our first 4 terms of the sequence. We have 4, then 9, 19, 39. Okay, let's look at another example. This is going to give you the first term of 4. And let's see here. This is n plus 2. This is not necessarily recursive. This is just an example of a sequence. Okay, so we have our first term is 4, so we'll go to a sub 2. Let's see, we've got negative 1 to the n, so that'll be 2 plus 2. And then times n, which is 2 squared. Okay, so this is not recursive because we're not using a previous term. We're just using our n here. So negative 1 to the 4th times 2 squared. So let's see here. Negative 1 to the 4th would be a positive 1. 2 squared would be a positive 4. Our a sub 2 is going to be 4. Okay, then we want a sub 3, so we're going to plug that in. We've got negative 1 to the 3 plus 2 times 3 squared. So this is negative 1 to the 5th times 3 squared. So this is going to be negative 1 times positive 9. So that'll be negative 9. And then we'll do our 4th term here. Let's see here. Negative 1 to the 4 plus 2. And then 4 squared. So negative 1 to the 6. It's going to give me a positive 1. 4 squared, 16. So a sub 4 is going to be 16. And then you can start to see the formula here. You have the first term is 4, second term is 4, third term negative 9, fourth term 16. So it looks like it's the square of the term, and then you're just doing opposite here. So the next one would probably be negative 25, then positive 36, etc. Okay, so what I want you guys to do now is pause the video and do these practice problems and then come back on and we will go over them. Okay, so first 5 terms of this sequence here, we're just going to plug 1, 2, 3, 4, and 5 in. So a sub 1, we've got negative 1 to the first times 1. So negative 1 to the first is negative 1 times 1. So that's going to give us an a sub 1 of negative 1. Then we'll do a sub 2. That'll be negative 1 to the second times 2. So negative 1 squared is positive 1 times 2 will give us a positive 2. A sub 3, we get negative 1 cubed times 3. So negative 1 cubed is a negative 1 times 3. That's going to give us a negative 3. So we start to see the pattern here. It looks like we're just changing signs. We can keep going, checking it. Negative 1 to the 4th times 4. It's going to be positive 1 times 4, so that's going to give us a positive 4. Next one should be negative 5. Let's see. Negative 1 to the 5th will give me a negative 1 times 5, negative 5. So we get negative 1, 2, negative 3, positive 4, negative 5. Okay, next one we have a recursive sequence. So let's go through here. So we have, let's see, the first 5 terms of the sequence. A sub 1 is negative 2, so let's go straight to a sub 2. That's going to be, let's see, a to the 2 minus 1 plus 3. So this is a sub 1 plus 3. A sub 1 is negative 2. So this will be negative 2 plus 3. So it's going to give us an a sub 2 of positive 1. All right, then a sub 3, we're going to get a sub 3 minus 1 plus 3. So it's just the previous term plus 3. That's our pattern here. So a sub 3 is going to be, let's see here, previous term was 1 plus 3, so 4. So just the previous term plus 3, which means if a sub 1 is negative 2, a sub 2 is 1, a sub 3 is 4, we add 3, the next one 7, next one 10. Okay, the last problem is a word problem, so I think I have to give you a formula for this. Hold on. Oh, it's right here, okay. B to the n minus 1. Okay, so John has a balance on his Discover card that charges 22% interest per month on any unpaid balance. John can afford to pay $200 towards the balance each month. His balance each month after making a $200 payment is given by the recursively defined sequence below. Find John's balance after making 6 payments. So we have to go all the way to B sub 6. So, okay. So we can't just plug the 6 in here. We have to actually go with each payment because each time it's going to be a little bit different. So we set this up here. This is, let's see, B sub n is 1. So we're going to start with our first payment. Okay. So we've got here, let's see, B sub 1 is going to be 1 plus our rate over the number of times we're compounding. So this is 22%, so 0.22 divided by 12 times b to the n minus 1. So this would be b to the 1 minus 1 here, and then minus 200 is his payment that he's doing here. Okay, so b to the 1 minus 1, that's b sub 0. So this is going to be 1 plus, let's see here, 0.22 over 12. Actually, let's go ahead and just get that. So 1 plus 0.0183, so 1.0183 here. Okay, and this is b to the 1 minus 1, so it's b sub 0. Well, b sub 0 is 4,000. It's going to be 4,000 minus 200. Okay, so his first payment, his balance will be, let's see. So this times 4,000 minus 200. So $3,873.33. So that is his balance after his first payment. Okay, then we're going to do the same thing for B sub 2. So we're going to go here, B sub 2. We'll do the same thing here. So it's going to be a 1.0183 times his previous balance, which is B sub 2 minus 1. So that's B sub 1, and then minus 200. So I'm just going to keep going on my calculator here. I'm going to go times 1.0183 and then minus 200. So that's his balance after his second payment, which is 3,744.22. Okay, so then let's do the third one. So if we did B sub 3, it would be the same thing here. So you would do the balance times the 1.0183 and then minus 200. So after the third payment, $3,612.73. Okay, then we got fourth payment. We will multiply by 1.0183 and then minus 200. So $3,478.85. And then we got 2 more. Okay, so then we will multiply by 1.0183, subtract 200 again. That's going to give us $3,342.51. And then last one. So $3,203.68. Okay, it was 68. Okay, so his balance after 6 months is $3,203.68. So he spent 6 months paying $200, so $1,200 from an original balance of $4,000, and he really only made leeway of, let's see, of $796.32. So let's see how much he paid in interest there. So he paid $403 in interest in that time period. So 403 out of 1,200, 34% there of his payments went towards interest. Even though it's a 22% interest rate, you've got to think it's divided over 12 months. So this is how the credit card companies are working here. Okay, next thing we're going to go on to is some sequences. So the next type of sequence we have is called Convergent and Divergent. So the first thing we have is a convergent sequence. A convergent sequence is where the terms get closer and closer to a real number. It converges to that number. And then the sequence that is not convergent is divergent. Okay, so basically this. If it just keeps getting bigger and bigger without bound, it's divergent, like this, n squared. This is just going to keep getting bigger and bigger and bigger. It's not going to approach any one number. An example of a convergent one is going to be like where negative and positive, like the one that we had where it was this. Okay, as you keep adding that, it's going to keep going towards one number because you're going to add one extra, but then you're going to keep subtracting. So something like that, or the fractions in the very first one as well, that's a convergent sequence. Summation notation. Okay, so now let's look at some series here. This is just going to be the way that you write a sequence, so it's just a different way of writing it. You have sigma, okay, this sign right here, that is the uppercase Greek letter S. That indicates sum in mathematics. It means you're adding the terms together. Sigma notation looks like this. So you have the sigma, and then on the, sometimes it's next to it, sometimes on the top. So n is the number of terms that you're starting with. And then I equals 1, that's where you're starting with. So it means add the terms of your sequence, so a sub I, beginning with the first term and ending with the nth term. So I is the index of summation. Difference between finite and infinite. Finite will have an n on the top. Infinite has this little infinity symbol. So let's look at some examples here. So this first example, it says evaluate. So what this is saying is find, okay, a sub 1 through 6 and add them together. So the sum of the first 6 terms of the sequence. That's what that is telling you. Sum terms 1 through 6 of the sequence. Okay, start on the bottom, end on the top. So we do this. 2 to the first plus 1 will give us 3. 2 squared plus 1, that's 4 plus 1, 5. 2 cubed is 8 plus 1, that'll give us 9. 2 to the fourth is 16 plus 1 will give us 17. 2 to the fifth is 32 plus 1 will give us 33, and 2 to the sixth should be 64. Oh, that should be plus 1. We got plus 1, 65. Okay, so we get the first 6 terms, and then we add them together. So we do 3 plus 5 plus 9, 17, 33, 65. So we get 132. Okay, the second one says sum terms 3 through 6 of the sequence. So you have to look at what the term on the bottom is, because it's not always going to be 1 through something. So this is terms 3 through 6. And then this sequence here, just a sub j, is just the term. So a sub 3 is just going to be 3. in this case. So, and then a sub 4, 4, then 5, and 6. So 3 plus 4 plus 5 plus 6 is 18. Okay, so that's what you're doing here with these sums. So that puts an end to 12.1. So the next one we'll look at different types of sequences and series.